Hello guys, today's problem is 3006 fourth problem, Trionic Array II. In that you are given an integer array called nums. Our task is to find a contiguous subarray, a continuous slice of the array, whose shape looks like up, down, up, and return the maximum possible sum of such a subarray. This special subarray is called a trionic subarray. Subarray trionic conditions are: for a chosen subarray from index L to R, there must be two turning points. P where the array stops increasing and starts decreasing. Q where the array stops decreasing and starts increasing. And they must satisfy: from L to P strictly increasing. From P to Q strictly decreasing. From Q to R strictly increasing. All three parts must have at least one step, no empty parts. Let's think in visual. Think of the array as a road with slopes that you are driving on. You start at some point and the road must first go uphill, meaning every next number is larger than the previous one. After reaching a peak, the road must then go downhill, where every next number is smaller than the previous one. This downhill continues until you reach a valley. From that valley, the road must climb uphill again, with values increasing strictly until the end of the subarray. Visually, this looks like drawing a check mark with a dip in the middle, up, then down, then up again. While scanning the array, you are essentially looking for this exact shape inside a continuous window and then adding up all the values inside that window. Among all such up, down, up shapes, you choose the one whose total sum is the largest. Let's understand this example step by visualizing the shape inside the array. In the first example, the array is 0, -2, -1, -3, 0, 2, -1. We are looking for a continuous subarray that first goes up, then down, and then up again. We choose the subarray starting at index 1 and ending at index 5. So the subarray becomes -2, -1, -3, 0, 2. First, look at the left part, -2 to -1. This is strictly increasing because -2 is less than -1. Next, from -1 to -3, the values go down. This satisfies the strictly decreasing part. Finally, from -3 to 0 to 2, the values increase again. That completes the required increase, decrease, increase pattern. Now we simply add all the values in this subarray. -2 plus -1 plus -3 plus 0 plus 2 gives us -4. That is the maximum sum possible for any trionic subarray in this input. Now let's look at the second example. The array is 1, 4, 2, 7. Here, the entire array itself forms a trionic subarray. From 1 to 4, the values increase. From 4 to 2, the values decrease. And from 2 to 7, the values increase again. So visually, this array already has the perfect up, down, up shape. When we add all the elements 1 plus 4 plus 2 plus 7, we get 14, which is the maximum possible sum. Let's walk through this solution step by step and understand how it finds the maximum trionic subarray sum. First, remember what a trionic subarray looks like. It has three parts in order: strictly increasing, then strictly decreasing, and then strictly increasing again. Our goal is to find any contiguous subarray with this shape and return the maximum possible sum. We start by iterating through the array using an index pointer. This pointer represents a potential peak where the decreasing part might begin. Step 1. Find the decreasing section. From the current index, we try to move forward while values keep going down. As we move, we add these values into a variable called decreasing_sum. If we cannot form a decreasing sequence, we skip this index and move forward. Step 2. Expand to the left. Once we have a valid decreasing section, we try to expand leftward from its start. Here, we look for a strictly increasing sequence. As we move left, we keep adding values and track the maximum left side sum we can form. This ensures we pick the best increasing part on the left. If no valid increasing part exists, we discard this attempt. Step 3. Expand to the right. Next, we expand rightward from the end of the decreasing section. Again, we only continue if values are strictly increasing. Just like on the left side, we keep track of the maximum sum we can get on the right. If this right increasing part doesn't exist, We move on. Final calculation. If all three parts exist, left increasing, middle decreasing, right increasing, we combine their sums and update our answer. To keep things efficient, we jump our index directly to the end of the right section, avoiding unnecessary checks. At the end, if we never found a valid trionic subarray, we return 0. Otherwise, we return the maximum sum we calculated. This approach carefully builds the trionic shape while always choosing the best possible contribution from each section. Now let's run the solution. And everything looks good. The logic correctly handles negative values, overlapping trionic segments, and edge cases where a valid trionic subarray does not exist. Let's submit the solution. And accepted. And that's it for Trionic Array II. This problem is a great example of combining pattern recognition with careful traversal. Instead of brute force, we smartly expand left and right around a decreasing core. If this explanation helped you understand trionic arrays clearly, don't forget to like the video, subscribe for more LeetCode breakdowns, and drop a comment if you want a dry run or visualization for another example. The solution link in description. See you in the next one.